We'll see some results. First, even and odd functions. A function f of x is said to be an even if f of minus x is equal to f of x. For example, you can take f of x is equal to x square. So f of minus x is also x square. So in this case, f of minus x is equal to f of x. It's an even function. Similarly, you can take cos x, trigonometric function. So cos of minus x is equal to cos x. That is also a even function. Some example. Next, we will see a function f of x is said to be an odd if f of minus x is equal to minus f of x. For example, you can take f of x is equal to x. F of minus x is minus x minus f of x. That is odd function. For example, trigonometric function sin x. Sin of minus x is equal to minus sin x. So product of even function is an even function. Product of even and odd is an odd function. And the product of two odd functions is an even function. It's like minus plus. Odd function is minus. You take just even function is plus. So plus into plus, plus, plus into minus, minus, minus into minus, plus. Some properties of definite integral. Minus a to plus a f of x dx, which is equal to 2 times 0 to a f of x dx if f of x is an even function. Right. Similarly, for the odd function, minus a to plus a f of x dx, which is equal to 0 if f of x is an odd function. So integral value is 0 for odd function, limit minus a to plus a. Next, De Moivre's theorem, e power ix is equal to cos x plus I sin x. Next, integral formula, integral u dv, which is equal to uv minus integral v du. Integration by parts. So next we will see a problem. If the power spectral density of a WSS process is given by S omega, which is equal to B by A into A minus mod omega if mod omega less than or equal to A, 0 if mod omega greater than A. Find the autocorrelation function of the process. We'll see the solution given S omega, which is equal to B by A minus mod omega if mod omega less than or equal to A. That means omega is sliced between minus a to plus a, 0 otherwise. That is equation number 1. We know autocorrelation or xx of tau, which is equal to 1 by 2 pi integral minus infinite to plus infinite power density function s omega e power I omega tau d tau. We know or autocorrelation, which is equal to inverse Fourier transform of power density function. So that is what we are using, that formula. Now, which is equal to 1 by 2 pi minus a to plus a b by a into a minus mod omega e power I omega tau d tau, right, which is equal to 1 by 2 pi integral minus a to plus a b by a minus mod omega. So we are replacing e power I omega tau, which is equal to cos omega tau plus I sin omega tau d tau, right. Now we are splitting the integral. So autocorrelation, which is equal to 1 by 2 pi integral minus a to plus a b by a minus mod omega cos omega tau d tau, second integral d omega plus second integral minus a to plus a b by a minus mod omega I sin omega tau d tau. That is equation number 2. Let the first integrand, that is a minus mod omega cos omega tau d tau, is f of omega. Let f of omega is equal to first integrand and g of omega is equal to second integrand b by a minus mod omega I sin omega tau. Now first take the first one, replace omega by minus omega. So you will get f of minus omega, which is equal to b by a minus modulus minus omega cos minus omega tau. We know modulus of minus omega mod omega and cos of minus omega cos omega, because cos is a even function. So b by a minus mod omega cos omega tau, right, cos omega then even function. So f of minus omega equal to f of omega. So f of omega is an even function. Therefore we are using properties of definite integral. integral minus a to plus a f of omega can be written as 2 into integral 0 to a f of omega d omega. Similarly, take the second one, g omega. Replace omega by minus omega. You will get b by a minus modulus minus omega, I sin omega minus omega tau. We know sin minus omega minus sin omega because sin is an odd function. This implies g omega, which is equal to minus b by a minus modulus tau, I sin omega tau. So g omega, which is equal g of minus omega, which is equal to minus g omega, right? Though g is an odd function, so using the definite integral formula, minus a to plus a g omega d omega, which is equal to 0. So using these two ideas in equation number 2, so we will get autocorrelation r of tau, which is equal to 1 by 2 pi. First integral becomes 2 integral 0 to a b by a minus omega cos omega tau d tau, because we are replacing mod omega into omega because the interval is 0 to a, positive. In positive value, mod omega is nothing but omega, right? That is why we remove the modulus value. So 2 and 2 cancel, you will get 1 by pi integral 0 to a b by a minus omega cos omega tau d tau, which is equal to, we are taking b by a outside the integral, b by a pi integral 0 to a minus omega cos using b by minus omega cos omega sin omega tau by tau. So we are using the formula integral u dv, which is equal to uv minus integral v du. So b by a pi, so a minus omega u, v is sin omega tau by tau, uv, right? U into v, the limit is 0 to a, minus integral v du. So minus b by a pi integral 0 to a, v is nothing but sin omega tau by tau, into du, u is nothing but a minus omega. Derivative of a minus omega is nothing but derivative of a 0, derivative of minus omega minus d omega. So we are substituting the upper limit and lower limit for the first term. So upper limit a, replacing omega by a minus a sin a tau by tau, minus replacing omega by 0, the lower limit a minus 0 sin 0 tau by tau, minus the second integral becomes b by a pi integral 0 to a sin omega tau by tau minus d tau. So this minus, already you are having one minus outside the integral, so minus into minus plus. So in the first expansion, first term, a minus a 0 sin 0 0, so first term and second term both are 0, so b by a pi into 0, so first term vanishes. So second term plus b by a tau pi integral 0 to a sin omega tau d tau. So now we are integrating sin omega tau. We know integral sin ax dx, which is equal to minus cos ax by a, right? So we will get minus cos omega tau by tau integral 0 to a. Upper limit is a, so minus cos a tau by tau, minus lower limit 0 minus cos 0 tau by tau. We know cos 0 equal to 0, so minus into minus plus, second term becomes plus 1 by tau. So yeah, I am writing in the front. So b by a tau pi 1 by tau minus cos a tau by tau. So tau is common in the denominator, so we are taking outside b by a tau square pi 1 minus cos a tau. 1 minus cos 2a formula, which is equal to 2 sin square a. A is nothing but a tau by 2, right? Because cos 2a is nothing but cos a tau here. So 2a is equal to a tau, so a is equal to a tau by 2. So b by a tau square pi 2 sin square a tau by 2. Therefore autocorrelation, which is equal to 2b by a tau square pi sin square a tau by 2. Thanks. We'll see in the next video. Thanks.